Right now, as you watch this video, is time really passing? Or is it just an illusion? From Einstein's relativity to quantum physics, some of the greatest minds in history have argued that time might not be what we think it is, or that it doesn't even exist at all. Let's dive deep into the science, the philosophy, and the mind-bending paradoxes that challenge our very perception of reality. Part 1. The two faces of time. For centuries, we've seen time in two main ways. As an objective, flowing river, carrying all events forward, the Newtonian view. Or as a mental framework we humans invented to make sense of change. Modern physics, however, tells us something far stranger. Our perception of time may have little to do with its true nature. Part 2. Quantum mechanics. At the quantum level, time doesn't behave like we expect. The Schrödinger equation, the core of quantum mechanics, is time symmetric. Reverse the math, and particles would happily run the movie backward without breaking any rules. But there's a catch: the observer effect. When you measure a quantum particle, you collapse its wave function into one definite state. That collapse breaks the symmetry, introducing irreversibility. Then there's entanglement, two particles linked so closely that changing one instantly affects the other, even light years apart. That's faster than time itself should allow, challenging our deepest assumptions about causality. Part 3. A timeless universe? Physicists Wheeler and DeWitt tried to unite quantum mechanics with Einstein's relativity, and ended up with something shocking. The Wheeler-DeWitt equation, which doesn't even contain time. At the most fundamental level, the math describes a universe that simply is a superposition of all possible states, with no ticking clock at all. Part 4. Time in classical physics and thermodynamics. In classical physics, Newton's laws are also reversible, but real life? Not so much. Why? Entropy. The second law of thermodynamics tells us that disorder always increases. That's why you never see a shattered glass reassemble itself. The thermal time hypothesis goes further. Maybe time isn't a fundamental dimension at all. Maybe it emerges from entropy. If everything in the universe reached perfect equilibrium, time would simply stop. Part 5. Time as information. The Bayesian interpretation suggests that time isn't out there in the universe. Instead, it's just a way for us to update information. In this view, time is less like a flowing river, and more like a filing system for our memories. Part 6. The human perception of time. Our brains play tricks on time. Dopamine can speed it up, which is why hours vanish when you're having fun. Fear slows it down. Your amygdala processes more data, making moments feel longer. In other words, the flow of time you feel might just be a neurological illusion. Part 7. Relativity and time dilation. Einstein proved that time is relative. It ticks differently depending on your speed and the gravity you're in. Live at sea level, you're aging a fraction of a second slower than someone in the mountains. Travel near the speed of light? Years might pass for everyone else while only months pass for you. Near a black hole singularity, time itself stops. Part 8. The block universe. Some physicists see the universe as a four-dimensional block where past, present, and future all coexist. Like the pages of a book, they're all already there. We just experience them one at a time. If that's true, then the future isn't waiting to happen, it already exists. Conclusion. So, is time an illusion? Relativity shows it's not absolute. Quantum mechanics hints it may emerge from deeper timeless laws. Neuroscience shows it's shaped by perception. Maybe time isn't the river we thought, but the map we use to navigate reality. One thing's certain: whatever time truly is, its effects are very real. If you enjoyed this deep dive into the nature of time, hit that like button, subscribe for more mind-bending science, and let me know in the comments, do you think time is real, or just an illusion?